Running non-metallic sheathed cable, or NM cable, inside of polyvinyl chloride, or PVC, raceway beneath a wooden deck in a damp or wet location has both advantages and disadvantages. Firstly, the National Electrical Code, or NEC, permits the use of PVC raceway in wet locations, including underneath decks. Secondly, the PVC raceway provides supplementary protection against water infiltration and moisture-related damage. Thirdly, the raceway protects the NM cable from physical damage from foot traffic, lawnmowers, and other things. Fourthly, the raceway makes electrical wiring more organized and accessible because it is simple to install and attach to the underside of the deck. However, PVC raceway may be more expensive than other NM cable protection techniques like conduit or cable ties. If the raceway is not properly sealed or ventilated, condensation may occur within it, which may cause NM cable corrosion. The length of NM cable runs may also be restricted by the raceway. Additional junction boxes or splicing may be needed as a result. Finally, it can be challenging to remove the raceway if the NM cable has to be accessed for maintenance or repairs. The raceway needs to be firmly fastened to the deck to prevent cable movement and damage. Use NM cable that has been approved for usage in wet locations. To avoid moisture penetration, seal all raceway joints and apertures with waterproof sealant. To reduce condensation, think about utilizing a raceway with a ventilated design. The use of NM cable and PVC raceway under a wood deck in a wet location is typically a secure and code-compliant choice. It's crucial to take into account the costs, potential for condensation, cable run restrictions, and ease of access before making a choice. You can create a secure and dependable electrical wiring system under the deck by adhering to appropriate installation procedures and taking safety measures to address any potential issues. In more detail, exploring the advantages further. Firstly, code compliance is paramount. The NEC outlines acceptable wiring methods for various environments. Using PVC raceway in a wet location, like under a deck, aligns with these regulations, ensuring the installation meets safety standards and is less likely to face rejection during inspections. Secondly, moisture protection is crucial for electrical wiring longevity. NM cable is not designed for direct exposure to moisture. The PVC raceway acts as a barrier, preventing water from coming into direct contact with the cable's conductors, reducing the risk of short circuits, ground faults, and corrosion. Thirdly, mechanical protection extends the life of the wiring. Decks are often subject to foot traffic, falling objects, and the occasional encounter with lawn equipment. The raceway shields the NM cable from these potential hazards, preventing damage to the insulation and conductors, which could lead to safety issues. Fourthly, ease of installation can save time and effort. PVC raceway is lightweight and easy to cut and assemble. It can be attached to the underside of the deck using readily available hardware. This makes the wiring process more manageable, especially for DIY enthusiasts. Shifting focus to the disadvantages. Firstly, the cost factor should be considered. PVC raceway adds to the overall cost of the project. Alternatives like cable ties may seem more economical upfront. However, the long-term protection and durability offered by the raceway can outweigh the initial cost difference. Secondly, the potential for condensation needs careful attention. Temperature fluctuations can cause moisture to condense inside the raceway, particularly in humid environments. This moisture can corrode the NM cable's conductors and connections. Using a ventilated raceway or sealing the ends with a moisture-resistant sealant can help mitigate this issue. Thirdly, cable run limitations may require adjustments to the wiring plan. The raceway's internal diameter limits the number of cables that can be run through it. If multiple circuits are needed, additional raceways or junction boxes may be necessary, adding to the complexity and cost of the installation. Fourthly, difficult access can pose challenges for future repairs or modifications. If a problem arises with the wiring inside the raceway, accessing it may require disassembling the raceway system. This can be time-consuming and potentially damage the raceway or the surrounding deck structure. Proper planning and installation techniques can minimize this risk. Now let's cover the additional considerations in depth. Firstly, securing the raceway to the deck is essential for preventing movement and damage. Use appropriate fasteners, such as screws or clamps, to attach the raceway firmly to the deck joist or framing. Ensure that the fasteners are rated for outdoor use and can withstand the elements. Secondly, using an M cable rated for wet locations is a crucial safety measure. While the raceway provides a degree of protection, it's not a substitute for using cable that's designed to withstand moisture. Look for an M cable with a wet location or outdoor rating. Thirdly, sealing all joints and openings in the raceway is vital for preventing moisture intrusion. Use a watertight sealant specifically designed for electrical applications to seal the joints between raceway sections and around any openings where cables enter or exit the raceway. Fourthly, considering a ventilated raceway design can help minimize condensation. These raceways have small openings that allow air to circulate, reducing the buildup of moisture inside the raceway. However, be sure to choose a ventilated raceway that's still rated for wet locations. In summary, using an M cable and PVC raceway under a wood deck offers a balance of benefits and drawbacks. Code compliance, moisture protection, and mechanical protection are significant advantages, while cost, condensation potential, cable run limitations, and access difficulties need careful consideration. By following proper installation guidelines, using appropriate materials, and taking precautions to mitigate potential issues, you can create a safe and reliable electrical wiring system under your deck that meets your needs and complies with electrical codes. Thinking about the specific NEC requirements is important too. The NEC covers various aspects of electrical installations, including wiring methods, conductor types, and protection requirements. When running an M cable and PVC raceway under a deck, several NEC articles are particularly relevant. Firstly, Article 300 covers general wiring methods, including requirements for protection against physical damage, proper support, and identification of conductors. Secondly, Article 310 addresses conductors for general wiring, including ampacity, insulation types, and installation requirements. Make sure the NM cable you select is rated for the intended voltage and amperage of the circuit. Thirdly, Article 334 specifically covers an M cable, outlining its permitted uses, installation requirements, and limitations. Pay close attention to the restrictions on using an M cable in wet locations and the need for supplemental protection. Fourthly, Article 352 covers PVC conduit, including its permitted uses, installation requirements, and support requirements. Ensure that the PVC raceway you select is suitable for the intended environment and is properly installed and supported. Remember, electrical codes are subject to change, so always consult the latest edition of the NEC and local electrical codes to ensure compliance. Consulting with a licensed electrician can also provide valuable guidance and ensure safe and code-compliant installation. Now let's delve into the topic of selecting the right NM cable for the job. An M cable comes in various sizes and configurations, each designed for specific applications. When choosing an M cable for use in a PVC raceway under a deck, consider the following factors. Firstly, ampacity is the maximum amount of current the cable can safely carry. Select a cable with an ampacity that's appropriate for the circuit it will be serving. Consult the NEC tables for ampacity ratings based on conductor size and insulation type. Secondly, conductor size is determined by the ampacity requirement. Larger conductors can carry more current. Common sizes for residential wiring include 14 American wire gauge or AWG, 12 AWG, and 10 AWG. Thirdly, insulation type is critical for wet locations. Look for NM cable with the THWN or THHN/THWN insulation rating. These cables are designed to withstand moisture and are suitable for use in damp or wet environments. Fourthly, the number of conductors depends on the circuit requirements. An M cable typically comes with 2 or 3 conductors plus a ground wire. Choose a cable with the appropriate number of conductors for the circuit you're wiring. Remember to always de-energize the circuit before working on any electrical wiring. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you're not comfortable working with electricity, hire a qualified electrician to perform the work. exploring the topic of properly sealing the PVC raceway. Sealing all joints and openings in the raceway is essential for preventing moisture from entering and damaging the NM cable. Use a watertight sealant specifically designed for electrical applications. Follow these steps. Firstly, clean the surfaces to be sealed. Remove any dirt, debris, or moisture from the surfaces of the raceway and fittings. Secondly, apply the sealant liberally. Apply a generous amount of sealant to the joints between raceway sections and around any openings where cables enter or exit the raceway. Thirdly, ensure complete coverage. Make sure the sealant completely fills any gaps or voids. Fourthly, allow the sealant to cure. Allow the sealant to cure according to the manufacturer's instructions before energizing the circuit. In addition to sealing the joints, consider using waterproof connectors and fittings to further enhance the moisture resistance of the raceway system. These connectors have built-in seals that prevent water from entering the raceway. Furthermore, let's discuss the importance of proper grounding when running NM cable in PVC raceway. Grounding is a critical safety measure that helps protect against electrical shock and equipment damage. When running NM cable, a grounding conductor, typically a bare copper wire, must be included in the raceway and connected to all metal enclosures and equipment. Here's why grounding is important. Firstly, it provides a low impedance path for fault current to flow back to the source. If a fault occurs, such as a short circuit, the fault current will flow through the grounding conductor, tripping the circuit breaker or fuse and energizing the circuit. Secondly, it helps to equalize the voltage potential between different metal parts. This reduces the risk of electrical shock if someone comes into contact with a metal enclosure or equipment that has become energized due to a fault. Thirdly, it helps to protect sensitive electronic equipment from damage due to voltage surges or spikes. A properly grounded system can help to divert these surges to ground, preventing them from damaging electronic components. When installing a grounding system, follow these guidelines. Firstly, use the correct size grounding conductor. The size of the grounding conductor must be appropriate for the size of the circuit conductors. Consult the NEC tables for grounding conductor sizing requirements. Secondly, connect the grounding conductor to all metal enclosures and equipment. Use grounding screws or lugs to securely connect the grounding conductor to all metal parts of the electrical system. Thirdly, ensure a continuous grounding path. The grounding path must be continuous from the service entrance to the furthest point on the circuit. Any breaks or discontinuities in the grounding path can compromise the effectiveness of the grounding system. Fourthly, test the grounding system. After the installation is complete, test the grounding system to ensure that it's functioning properly. Use the grounding tester to verify that the grounding impedance is within acceptable limits. Understanding the limitations of NM cable is key to using it safely and effectively. NM cable is designed for specific applications and has limitations that must be considered. Here are some of the key limitations of NM cable. Firstly, it's not suitable for direct burial. NM cable is not designed to be buried directly in the ground. It must be installed in a conduit or raceway for underground applications. Secondly, it's not suitable for use in hazardous locations. NM cable is not permitted in hazardous locations, such as areas where flammable gases or vapors are present. Thirdly, it's not suitable for use in high-temperature environments. NM cable is not designed to withstand high temperatures. It must be protected from excessive heat. Fourthly, it's susceptible to damage from physical abuse. NM cable is relatively fragile and can be easily damaged by physical abuse. It must be protected from impact, abrasion, and other forms of physical damage. Being aware of these limitations will help you choose the right wiring method for your application and ensure a safe and reliable electrical installation. To further enhance safety, consider using arc fault circuit interrupters, or size, and ground fault circuit interrupters, or DFCIs, in circuits that serve outdoor outlets or equipment. A size protects against arc faults, which are a common cause of electrical fires. GFCIs protect against ground faults, which can cause electrical shock. These devices can provide an additional layer of protection for you and your family. Arc fault circuit interrupters, or RFCIs, are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. Arc faults occur when electrical current strays from its intended path and creates an arc, or spark. This can happen due to damaged insulation, loose connections, or other factors. RACWAYs work by monitoring the electrical current and detecting the unique characteristics of arc faults. When an arc fault is detected, the RACWAY trips the circuit breaker, cutting off the power to the circuit and preventing a fire from starting. RACWAYs are particularly important in bedrooms and other areas where people sleep, as they can provide early warning of a fire and allow time for escape. Ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults, which are electrical conditions that can cause electric shock. Ground faults occur when electrical current leaks from a circuit to ground. This can happen if someone touches a live wire or if there's a fault in an appliance or piece of equipment. GFCIs work by monitoring the electrical current and detecting any imbalance between the current flowing to and from the circuit. If an imbalance is detected, the GFCI trips the circuit breaker, cutting off the power to the circuit and preventing electric shock. GFCIs are required in bathrooms, kitchens, and other areas where water is present, as well as outdoors. In conclusion, running NM cable and PVC raceway under a wood deck in a wet location is a viable option, but it requires careful planning, proper installation, and adherence to electrical codes. By understanding the pros and cons, considering the additional factors, and following the guidelines outlined above, you can create a safe and reliable electrical system that meets your needs and protects your property. Remember to always prioritize safety and consult with a qualified electrician if you have any questions or concerns.